Right, hi there. I don't know where to start. We've got this all up and running now on the board that's going to go in the electric box for the fibre laser. We've got proper power supply now. We've got a surprise. This is how it's going to lay out approximately. Like I say, this is a pulse direction EDS 3000, and it has its advantages over the EtherCAT for one main reason, which I'll go to in a minute. As you can see, it's alive. We got the heartbeat there for the timings and what have you. The old network cables are fishy flashing away, and over here we've got our got the software up and running. Those errors there are just because not everything's wired in. We've got this working, and I would like to just show you this working. So as you can see, that's working as a treat on the handheld with just the X-axis. Now, I got into a debate with somebody that I know about how can we go about making this even cheaper. Now, I'm not going to cheap out on this. It's just what I don't want to do is get myself into a fix where I have spent thousands upon thousands of pounds and I can't really get it to do the job as professional as I would like it to do. So what I've done is, this is a pulse direction EDS 3000. So what I've done, I've used a closed loop stepper. I've used a standard stepper driver. These are CWD 556 from CNC4U. This is just to test some theories of mine. That is a voltage converter, which I'll explain in a moment. And yeah, I've actually taken the jump now and ordered some hoofing NEMA 34s, I think NEMA 34 9 Newton meter closed loop steppers. Now, how do you get this to work on what is sort of a servo board is not that difficult when you know what you're doing. Which that was my first problem. I didn't have a clue what I was doing. I had no idea. But if you look at the manuals and you read them really, really closely for both closed loop steppers and the way in which encoders work, how they work, it's not a massive leap to make a closed loop stepper work on this predominantly servo driven board, or the board that drives servos. So if I explain to you what I've done, looking through the manuals, bit of a plug there for AGN, but not to worry. On the right, this lot is what comes out of the board. So you can see what I've done there is that I've got, I've labelled pin 1 as pulse plus, and pin 1 is the green cable. And I've gone down through like that. So pin 2 is yellow, and pin 2 is direction plus, and so on and so forth all the way down. Number 8, the brown black pin 8 was a bit of a problem, because that is to supply a 24 volt it's light flickering. It's to supply a 24 volt DC voltage to the encoder that goes on servos, and they're nearly always 24 volt, give or take. So I had a bit of a problem, because then when I go to my closed loop stepper, what it wants on its pin 8, which is wire red, pin 8 is 5 volts. Hence that little bit of voltage conversion there. You probably can't, oh, you can probably see it. Anyway, that's just stepping down 12 volts to 5 volts. Sorry, 24 volts down to 5 volts. You can see I have very agriculturally joined stuff with Wagos. There's another issue here, which I'll describe in a minute. But essentially, it's all the same. So you've got your step and you've got your direction. So you've got pulse and direction. Enable's sort of irrelevant. Then you've got your power into the driver, and you have your 2 coils in the closed loop stepper. So what you're effectively doing, you're powering a standard basic stepper driver. You're powering it, you're sending the signals to the coils, but you're only using the step and direction that comes from the ES3000. And then what you do, you get onto this little bit, which is the encoder, and you figure out what encoder lines are, referring back to my sheet, and you tie them into the appropriate wires that go back to the ES3000. One issue I did have, and I'll need to overcome it in a more professional way at a later date, is I ended up having to tie the alarm clear and the enable to ground. So it's in the manual. It says how they're activated and what have you. So the alarm is always being cleared. God, this flicker's driving me nuts. The alarm is always being cleared, and the enable is always enabled as it's dragged to 0. That took a little bit of figuring out because I still couldn't get it to work no matter what I did with that. But if you do both to ground, it seems to work. Some of these things in here we can sort of ignore. So when we're looking at the Z plus, and I believe there's a Z minus in here somewhere, I've just left those floating. They sit on there. It doesn't seem to affect the overall performance of the motor. It's going to be interesting to see what happens when we actually mount this to the machine. But I think if we can get it moving, it doesn't really matter how it moves within reason, as long as we can get it moving in a satisfactory manner. So that my key goals, if you like, are to have the movements as smooth as possible. So we're not going to direct drive off of these. We will do planetary gearboxes, probably 5 to 1. I think 10 to 1. 10 to 1 is what I put on the plasma. I'm not sure we'll get the rotational speed of a stepper fast enough to be able to cut fast enough. So that's why we've gone for quite big 9 Newton meter steppers, in the hope that we can drive a 5 to 1 gearbox, and that will give us the speed we need. I think I'm still shooting for 70 meters a minute. I don't think it's going to be possible off of steppers, but we'll have to see. There's a lot of tuning and a lot of jiggery pokery to go into it, and bear in mind that we're upping the amps, which is upping the power, which should help us with the acceleration and deceleration, but I'm not sure it helps us with overall top speed. So there you go. As a bit of a quick update, we are kind of this far. That wiring in the steppers, closed loop steppers instead of servos, let's just say that one decent servo driver and servo motor will set me back £1,000. I can get the whole kit for 600. So that's all 4 closed loop steppers, all 4 drivers. I can get the whole lot for 400, give or take £400 or £500. So it is a massive difference. It's a massive saving. It may bite me on the ass, but for now it's a risk I'm willing to take. If we can get when we build the table, if we can get it all moving and we get it moving at a decent rate of knots, it would be really, really cool. Because I don't know, I haven't seen anybody do this. Like I say, it's a bit agricultural, and the fact I haven't seen anybody do this means that maybe it shouldn't be done. Let us know in the comments below. It's not ideal. I do know the limitations of steppers as opposed to servos. At the end of the day, if we can get anywhere near our 70 meters a minute, bear in mind that in this country you should only go to 25 meters a minute before it's got to be enclosed and light curtain and all that kind of business. I'll be chuffed. I'll be very, very happy. If anybody wants to give this a go, by all means get in contact, and I'll tell you what I've used and how I've used it. In fact, you can pretty much see what I've used. There's a bog standard closed loop stepper. Cut the plug off. I wish I hadn't cut the plug off now, to be honest. It's a DB9 plug, and I should have left the darn thing on there, but it is what it is, because I could have just got DB9 connections and that would have been it. So now I've got to solder on DB9 connections and go through all that faff. But this is only a test rig. As far as the stepper driver is concerned, it's not a big stepper driver. So I think we've got maximum ampage here of 5.6. I have cranked it all the way up. The motor is moderate, tiny bit warm, but not anything too fancy. The handheld comes with a pretty snazzy little aerial, so you'd be able to pick that up from a decent distance away, because bear in mind that our table is 5.5 meters long. It's big, and it's the better part of 2.8 meters wide. So yeah, so it comes with all the little gubbins, and then you just plug it into the USB. So there's a USB hub there to help with that. Had to go USB to Ethernet converter. Seems to work really, really well. There didn't seem to be any problems with it. There's a bit of an issue with the encoder count on this. This is another one. Sorry, I keep flipping back. Another problem with the closed loop steppers is the encoders on them are not very fine resolution. So these are 1,000. I call it 1,000 pips, but it's 1,000 pips per revolution, 1,000 signals per revolution. I could do with adding a 0 onto that end of that as a minimum, really. We could buy plain steppers and put on our own encoders. There may well be closed loop steppers out there with 10,000 pips per revolution. I don't know whether it's going to be a benefit or no. I'm not really willing to spend too much time on it, because this machine will be servo driven at some point. This is just testing a theory, and it's not throwing bundles of money at it and finding that we cannot get a super fine machine, because as you know, I spent so much time on the plasma, and the plasma's come out on the money. It's a brilliant piece of kit, and I don't want to ruin a machine by taking shortcuts, but at the same time, laser is a little bit more finicky in some respects, because A, you need the speed, B, you need the power for the acceleration and deceleration, and you also need the accuracy. And I don't want to have ripples in the side of the cuts, if you like, because I haven't done something properly. So what I mean by that is that if you can feel the stepper pulsing, that's going to invariably show up in your final cut. So then in the quality of cut is going to be a little bit suspect, and I don't want to do that. So we will definitely go to servos when we get this working. All right. It's sort of really, I know I'm going to have to pay for the servos at some point. I know I'm going to have to pay for the drivers at some point. I wanted to get off with it at a good start. I didn't want to cut any corners. This just feels like a logical corner to cut. The whole idea is to get a 4 meter by 2 meter cut bed laser, fiber laser, 3 kilowatt for under £10,000. Now, this is going to help me do that. Now, are we going to get £10,000 worth of laser, or are we going to get £70,000-80,000 worth of laser machine for 10,000? If you get my drift. What I'm saying is you get what you pay for, yeah? So if I can do the whole thing for £10,000 plus my time on top, which I must admit I'm not counting, I'll be happy as a pig and do. If I can't get it to the quality of the cut very well, then I'm going to be a little bit disappointed. But looking at the plasma quality of cut, which I'll show you in a sec, it just seems to be that the system I'm using with the planetary gears and what have you does seem to make a difference. Which brings me on to something else about the encoders, actually. If I'm going to use 5:1 gear ratio, then does that not multiply the encoders? So would that make them not 4,000 pips per rotation? I don't know. My brain is not quite wired up to figure that one out. But that's where we are. So just another little update. I'm going to keep throwing them at you, whether you like it or no. And I just find this whole closed loop stepper thing fascinating. If it doesn't work, it doesn't work. I just chuck it in the fucking bucket and jobs are good. Excuse my language. And then we'll be able to, you know, we can move on. But the main thing is the driver board itself, although it is a pulse direction and not EtherCAT, although there's EtherCAT there. Beg your pardon? Yeah, it's not EtherCAT. It is what it is. I wanted to go this route so that I could do this. I mean, if I went all EtherCAT, then I wouldn't be able to do this. So fortune, yeah, a bit fortuitous to choose the pulse direction because it's what I know, but I have to say I never dreamt for a minute this would work, but it does. And I'll just show you again, it does work. Here is the handheld, here is the X, and that's singing along quite nicely. You can see, go along at a bit of a lick. There we have it. So there we go. The other thing I've done as well, just briefly, is a couple of the stops are wired in. You can see there. They work. So there we go. Bump, bump. I think I showed you this last time. If we go over to here, we can go up to File. We can go to Diagnostics, I/O Monitor. Brings up the I/O monitor, and you can see that I've got the X-axis. Yeah, I don't know why the focus axis is lit, but it is what it is. You can see the X-axis is lit as samples. Oh, and if I reach for the, there we go. So we can just activate it on there. As you can see, the light's on, and you can see that it is activated off, on, off, on. So that all works. We're going to use all of this type setup all the way through the machine this time. We're going to label every wire, will be numbered. We're going to produce a manual for all the connections, and we are actually building that as we go along, as far as we've got. But I'm going to go back to what I've already said. I don't know whether this is going to work. I don't really care. The fact that I've got it to work is, in my mind, slightly bonkers. And I had to be very, very careful. Obviously, you know, the step down of the voltages. You don't want to, you know, you don't want to just blow a closed loop stepper just for the hell of it because you haven't read the manual. I have got all the wirings here. If anybody is at all interested, if they do want a little look, they're there. Look, take a screenshot. It's all as it comes out of this board and as it comes out of these, you know, as it comes out of the thing. On the stepper itself, it does actually tell you, you don't necessarily need the manual, it tells you what all the outputs are, or sorry, for the, beg your pardon, for the encoder. So you've got the encoder model there, and you know, you've got all the wires that you need. All right, so you've got your A leg, B leg, EB plus, EB minus, EA plus, EA minus, VCC and ground. So it is there if you want it. These, if you know anything about steppers, they don't get much more basic than that. We're going to have a little bit of fun tuning it, but that's our problem for now, because we need to make sure we set all the microsteps up to suit the pulses that are coming out of there, to you know, to make sure that we got so many rotations to move a certain distance. We're going to decide on the teeth size for the pinion. We're probably going to go straight cut rack and pinion mod 1.5. I know it seems small, but it hasn't given us any problems with the plasma, so I don't know why it should give us any problems with anything else, to be fair. So there you have it. I think that it's going to work after a fashion. I repeat, I will go to servos, but at the moment, with the way in which things are a little bit constricted financially, I'm going to try this, and I have ordered it. So it's ordered from, I believe, just let me have a little tweaky poos here. Yeah, so we've ordered it from Steppers Online, and they do have data sheets and what have you for all the motors that they do. And we just went for Oh, let's have a look. So stepper drive controllers, we just went for big hairy ones. I think we went for 6 amp. Where are we? Oh well, it might have been even the 8 amps, so we might have even gone for that one there. But can you see what I'm saying about price? It's one of those, you know, how much do you spend on servos? I don't know. It's I might be gambling here, and I might be just throwing away 300-400 quid, but in my mind, I kind of figure it's worth it. That's in my tiny mind. But there we go. So that's where we're at. I'll show you that once more in case anybody is vaguely interested. That does work if you wire it up according to that. So your EA plus to your EA plus, and you've got several no connects in there. Though that's the color of the wires. You've got your 5 volt. Don't forget, if you do this for any mad reason, 24 volts, 5 volts. You need some kind of step down, buck boost, whatever you're going to use to get it down to 5 volts. You need to do that. You could, of course, just supply it its own 5 volt supply. There's no reason why you couldn't do that. The reason I've done it this way is this is the only 5 volt supply that I need. Otherwise, I'd have got a 5 volt one of them. And then you just, join the neutrals together, and you've got your universal power supply, if you like. It's a pity the board doesn't actually supply 5 volts. I don't see that it does. It wouldn't make sense to do it. It would be nice if you had a 24 volt output and a 5 volt output, but there must be some kind of design reason for that, and it makes sense. The last thing you want is noisy components being plugged into it and making the system do weird stuff. So there we go. Anyway, hope you like it. There's a bit of cleaning fluid and stuff in the background. Look, I hope you like it. This is where all the work's going to happen now for the board. We're going to wire in all the stops, all the Hall effect sensors, and we're going to start getting some of the lights working on the outputs. As you can see, there is nothing on the outputs at the minute. And yeah, once we get the rest of the motors pop in, which should be this week sometime, we'll wire all the motors in. We'll wire them all up according to this with proper GB line type connectors on, or whatever, however we see fit. And we're just going to get it all working, and we should, in theory, be able to watch it, sort of cut that stuff out, because at the moment you can run a simulation on it and it does its simulated cutting, blah blah blah. Nothing fancy about that. We know here that you can hear that all works. You can set your speeds and all kinds of stuff. This is I think it's quite a nice piece of software. It's not too difficult to get your head around. There's a few little niggles with it. The configuration software is something different again, to configure all the ports and pins, but again, it is relatively straightforward. Anyway, I'm rambling, so I'm going to have beer. I'm off out tonight. I'm going to have a couple of little drinkies, and I will see you on the next one. So if you like this, please like it. If you've got any comments at all, and I'm sure you will have some comments, because what crazy ass uses closed loop steppers on a very, very nice EDS 3000 system? This fool. This is the guy who uses it, and I'm just looking forward to giving it a bash anyway. So please like and subscribe. I've had a bit of a boost in subscriptions. Thank you all very, very much. I still need to set up Patreon channels and stuff like that, where there will be drawings and wiring diagrams, and everything will be there as we go along. We are documenting this heavily. That is not our documentation. That is just our notes. So it will be documented heavily. You will be able to build this using whatever you want. So you'll be able to use the EDS 3000. You'll be able to use closed loop steppers if you want to. You'll be able to use servos. As we go along, you will all get the updates, and all the plans and bits and pieces will be available. All right. I don't know whether I'll go down the list of, you know, full-on bomb of you need 2.2 meters of 100 by box section or something like that. But the dimensions will be on all the drawings given. And I will probably release the Fusion 3D, so the F3D files as well, so you can make your own adjustments to it. At the moment, until we build the table and we know it works, we sure as hell aren't going to release anything in case it doesn't work, and I do not want to suffer the wrath of the internet. So anyway, like I say, please like and subscribe. Every comment is valuable. I try to respond to every comment. I think I pretty much have. If it's just a, you know, if it's just a heart or a thumbs up or whatever, or you got any questions, or, you know, you got any solutions for me, then, you know, keep them coming. I don't mind, good, bad, indifferent. It makes no difference to me whatsoever, other than I want to make this work and I just want to share my work. So all the very best, God bless, and I will see you on the next one. Cheers.